today's topics about work, power and energy. In your previous sessions, we have encountered the idea of force, motion related terms, and the last session we know the flotation, Archimedes principle and those things. Now in this session we learn about work, power and energy. Now work, what is work? First of all, in case of definition of force, the external physical quantity which is applied on a body is called the force. It is applied because of its change the inertia of the body. Now in every time force changes this inertia, that not happen. Sometimes force displaces the body, sometimes doesn't. So there are different criteria or applied force. Now if a body having mass m is situated at that particular position and the situation that position is A, now you apply the force from this direction. As force is the vector quantity, so you have to specify the direction of the force. Now force is applied on this particular direction. Now if the body overcomes inertia, then the body displaces in this direction because of Newton's second law. Newton's second law states that the change in momentum should be take place in a particular direction in which the force is applied. So the body and the applied force is in this direction, so it is required that the body displaces at that particular direction. If that's so, if it is happened, then the force is said to be done some work. So this is another physical quantity which named is work, is nothing but whenever force is applied on a body and body displaces such amount, a particular amount, then it is said that the force do some work, and if it is not displaced any more, then it is called the force do not work any do not work. So let the position, final position after applying the force is B, and the distance, not distance, it is the displacement, because we calculate the shortest distance is S. So this is your force which is F applied on a particular body, and the body displaces by an amount which is S. Now by the definition of work done, what is that? The definition of work done is nothing but W, which is F into S. Now this is a vector sign over the head of the F and S. As it is a vector quantity, so we have to specify its direction as well as magnitude. The direction is symbolized by that arrowhead. Now it is the product of the two vector quantities. Now if the product is given by the two vector quantities, that would give either a vector quantity or a scalar quantity. In this case, work done doesn't depend on the direction, so it is a scalar quantity, and the product is called the dot product. Now if it is a dot product, then W equal to Fs cos theta. What is theta? Theta is the angle between the force and the displacement. So there is a particular case of angle made by force and the displacement. So W is nothing but Fs cos theta. Theta, cos theta is nothing but, if you draw a right angle triangle and say suppose it is your theta and it is a 90-degree triangle. Now for a 90-degree triangle, and with respect to, mind it, with respect to that theta, this is your height and this is your base and this is your hypotenuse. So this height by base gives you tan theta, and the base by hypotenuse, that gives you the cos theta component. Let it be ABC triangle, then from that ABC triangle cos theta is nothing but BC by AC. Why BC? BC is the base with respect to that angle, and AC is the hypotenuse with respect to theta. So cos theta is, in case of language of physics, if force is applied in that particular direction and displacement is in this particular direction, then theta is given by that quantity. So force is nothing, force is always directed parallel with the displacement. Not so. Force can be directed at any direction, but we have to specify the work done. That's why this whole quantity should be calculated if you calculate the amount of work done. So in one word, work done is nothing but the force times the displacement. So this is the quantitative definition of the force. If we say that force, that work done is nothing but the product of force and displacement, this is the quantitative definition of the work done. And if we say that if we apply a force and the displacement is in the direction of the applied force, then it is said that the force do some work. This is the qualitative definition of the work done. Now work done is having the product of force into displacement. We know that unit of force is Newton and the unit of displacement is Newton meter. So the unit of work done is Newton meter and it is simply joule. So the unit of work done either Newton meter or you can call it joule. So this is a work done, but the work done depend on the three things like the force applied, the displacement of the body and the angle made by force and displacement. Now if we actually calculate the work done which is 0 but there is an applied force, so we have the derive the condition of 0 work done. Now in case of 0 work done, 0 work done although force is applied, so the condition of 0 work done, this is the condition of 0 work done. First of all, if S equal to 0, we know W equal to Fs cos theta. Now put the value S equal to 0. So what happened? Work done is 0. So we say that if the displacement is not there but we apply the force, like a big stone is situated in a particular position but you apply a small amount of force but the stone doesn't work, doesn't do any kind of displacement, that means your work done should be 0. Now if that is the important case, if theta is 90 degree, if theta is 90 degree then cos theta, if theta is 90 degree then cos theta, that corresponds to cos 90 degree, that would give 0. So theta is the intermediate angle between the force and displacement. Now if the force and the displacement are at 90 degree angle, then the total work done should be equal to 0. Take an example, a man carrying a basket in his hand, in his head. Now the weight of the basket is downward, so this is the applied force and man is moving in this particular direction, so this is the displacement. Now this is the intermediate angle between the force and displacement which is 90 degree. So if this happens then the body or the man do not work because the intermediate angle between the force and displacement is 0. Work done is depend on that particular case. Whenever the man is moving in an upward direction or in a downward direction, then in upward case the force do some work. Why? Because in case of upward direction, the direction of the displacement is opposite with the applied force. The force is applied downward and the displacement is upward direction. So whenever displacement is in the opposite direction of the applied force, then the force do some work, but that work done should be a negative work done. And if the man moving downward direction with the applied force, that force is nothing but the gravitational force. So whenever the body do some work in the direction of the applied force, then it is called positive work done. So with respect to gravitational force constants of Earth, if the body displaces at the direction which is similar to the direction of the acceleration due to gravity, then it is the positive work done. And if it is in the opposite direction of the acceleration due to gravity, then it is called the negative work done. So there are two types of work done. One is positive work done and one is negative work done with respect to gravitational force. Thank you.